Today, we're diving into one of the biggest problems in tech that nobody talks about: heat. The AI models that power our lives are getting so powerful, they're creating a massive heat problem that's holding back progress. But Microsoft just revealed a breakthrough cooling technology that's a total game changer, and it's inspired by butterfly wings. Microsoft has found a way to water cool a computer chip from the inside. They're using etched microscopic channels the width of a human hair directly onto the chip and running liquid coolant through them. This is a huge deal because it's up to 3 times more efficient than old methods, which saves massive amounts of energy and unlocks the ability to build far more powerful and compact AI. What do you think about this, John?
I think this is cool. I think this is a huge breakthrough. I'll talk about the results quick, and then I'll get into the engineering. So the results of this, the microfluid system, can cool chips up to 3 times more efficiently than the best current technology, which reduces peak temperatures by 65%. So this means data centers can run more powerful AI models without overheating, use less energy for cooling, and potentially pack more cooling or more computing power into smaller spaces. So, like you talked about, it centers around in-chip microfluidics, which is a radical departure from conventional external cooling systems. As we know, you throw in some paste, you throw on an external heat sink, and that helps to cool the chip. But this technology involves etching ultra-thin channels directly into the back surface of silicon chips using advanced semiconductor fabrication techniques similar to those used in chip manufacturing. So these microchannels, with diameters comparable to the human hair, which is 50 to 100 micrometers, they're precisely carved into the silicon substrate to create a 3-dimensional network of fluid pathways that can route coolant directly to heat generating hotspots. So the challenge itself lies in achieving the optimal balance between channel depth and structural integrity, obviously. The channels must be deep enough to allow adequate cooling flowing rates without creating pressure drops that would impede circulation. Yet they have to be shallow enough to avoid compromising the mechanical strength of the silicon wafer. And so Microsoft, they've developed 4 distinct design iterations over the past year, and each refined through using computational fluid dynamic modeling and thermal analysis. And the final design incorporates variable channel geometries that adapt to specific heat signatures. I think this is a huge breakthrough that's not being covered. If this is actually going to happen, it seems like it is, but what are your thoughts, Craig?
Well, we're at an AI tipping point. You know, they're spending billions in the U.S. on Project Stargate with all those AI data centers. They're building that, what's it called, Wonderland or whatever out in Alberta, that Mr. Wonderful pushing their AI power data center out there. So the process are generating so much heat that traditional cooling methods like air conditioning and cold plates can't keep up. So this is a thermal bottleneck that limits how fast and powerful we can make AI. Plus, the current data center cooling system consumes so much energy. So tests show that a 65% reduction in chips' maximum temperature using this capability. This lets the chip run faster and more reliably. More power, less space, because it's more efficient, up to 3 times. So data centers can pack more chips into each server rack because they had to have so much space for airflow, so much stuff. So this is a big potential breakthrough, enabling totally new chip designs. For years, engineers have wanted to stack chips in 3D to make them more powerful, but they couldn't to solve heat problems. This technology can make 3D stacking chips a real possibility. So it's a massive win for data centers and AI sustainability, and potentially gives us a greener cloud. But, you know, I don't think it's green. Saying greener means it wastes a lot less energy, but it's still wasting a lot of energy. So
honestly, I don't think they're going to use this
achieve net zero.
To be net zero, they're going to use this to increase output power.
Yeah,
for sure.
Agreed. They're going to use this to pack more stuff, so the output will probably be just as high.
Exactly. It's still going to heat up just as much, but it'll be more powerful.
It sounds like they'll be putting 30% more chips in per rack, if by volume, if not more, this way. So we'll have to see how that goes. I love the concept because it really starts to change the way how chip designers, we could see that kind of stuff even in laptops at some point because of the way it's designed. A thicker chip with cooling actually running through it and stuff. So I'm really interested in where this goes.
Especially now because I think right now global data center electricity consumption is about 1% and it's projected to reach 8% by 2030. And on top of that, AI data center energy intensity consumes more power than traditional servers. So it's going to help, I think. I don't think it's going to help save energy. I think it'll just help us create more powerful chips.
Yeah, it saves more energy on a per chip level or a per cycle level or what have you. So they'll just cram more stuff into it so they can reach that maximum threshold again. I think I mentioned this, but the cooling technology is biomimetic. It's designed, is AI optimized to mimic the highly efficient natural patterns found in leaf veins and butterfly wings. So it has ripples in these ridges to help with the cooling that were designed by AI.
Just a side note, speaking of butterfly wings, I just saw that they did a butterfly monarch wing transplant, which took about 5 minutes to do. Crazy, right?
That is crazy. I have more questions than
I'll send you the article. But anyway,
yeah,
sorry.
we'll move on because we have to. But I'd like to ask more questions about that.
Yeah.
So there you have it. We're hitting a thermal wall, and Microsoft's answer is to build tiny leaf vein inspired liquid pipes right into the chip itself. It's an incredible piece of engineering that could make AI faster and greener. We'll be watching closely to see how fast the rest of the industry adopts it.
Yeah.
So what do you got going on, John?
Yeah, well, just helping companies secure government funding. So, it's a great time to reach out if you have any questions. How about you, Craig?
Well, there's a lot going on over at flowgrammer.ca. We're doing automation and AI and business processes. We do events, but we're really ramping our business up. And check out all the things we're doing over there. If you're interested in business automation, we've got community events where we're teaching everyone. We do an online, and we're about to launch our new resource center, flowgrammers.ca, which might be out when some of these are out. Other than that, check out for everything we do. Our monthly Startup Investor Drinks, where you get to pitch to the crowd, business owners and investors, and have real conversations and make real connections. So for all those things, check out TorontoStarts.com. And for everything else, anything else, John, before we say goodbye?
No, just reach out to me on LinkedIn, John Irwin, if you want.
John Irwin on LinkedIn. Thanks, everyone. We'll talk to you soon.